Feeling like taking a coffee break? So do I. We could talk about another preview feature of Java 14 called pattern matching for InstanceOf. Now, this may look a little mysterious, so let's check it out. This pattern matching for InstanceOf stuff is in fact the first step toward a much broader thing, which is pattern matching for Java. Maybe we'll talk about that in more details in the next episode. In the case of InstanceOf, it will allow you to simplify the syntax of having an instance of and then some code in the case of, yes, this object you're checking is indeed an instance of, let's suppose, a user class. I just created an instance of user class with two private fields, name and age, on a constructor, and in the middle of it I added an equals method, the kind of equal method that your IDE could generate for you, that is just comparing the name and the age of the people, and if they are the same, of course, the people will be equal. Now, here I have four instances of users. U1 and U3 are the same, they have the same fields, and I would like to check if U4, which is a variable of type user, is indeed an instance of the user class in the sense of the InstanceOf operator. So let me print out this boolean and see if it's the case. You see, InstanceOf is evaluated at runtime, not at compile time. So how is it going to behave? Maybe you already know that, but in case you don't, you're going to see it. So let us compile this code and run it. And you can see that B is false, meaning that in fact, a null value is never the instance of anything. Null value always returns false when evaluated with InstanceOf. So it means that we can get rid of this line of code here. And now if O is null, we will return false. So if it's not null an instance of user, we can execute the code that is there. Let me just copy paste this real quick and check that, yes, U1 is equal to U2. That should return false. Well, at least this is what I expect. And let us do the same for U1 and U3. And this time, I would like, of course, this to return true. So let me run this code. And indeed, U1 and U2 are different, and U1 and U3 are the same object, which is fine. Well, at least the same object with the same value. Now, if we check this code here, we can see that on the two lines, we are checking first that if O is an instance of user, and in the next line, we are going to cast this O in a variable of type user. And the idea behind pattern matching for InstanceOf is to precisely merge those two lines into one. Let me do that, say that this is a user, and get rid of this line. And now what I'm saying is the following. If O is an instance of user, then create a variable of type user that will be the same object as O. And now I can use this user variable as a variable of type user with all the methods and the fields behind this object. So let me compile this code with the preview. By the way, I could compile it with this -xlint stuff. And you can see that, in fact, it's very convenient to have that. It tells you exactly where in your code you have been using those preview features. So in case you have some preview feature code in your application code and you don't want to make it to production, but somehow it could leak to your CI/CD stuff, well, you can still locate very precisely where this code is and then fix it. So let me run this code now. And you can see that this code is still working, right? So we were able to create this variable as part of this instance of stuff. So let me show you something, because obviously this user variable means something in the case, yes, O is an instance of user, but it should not mean anything in the else branch, right? In the else branch, O is not an instance of user, so we should not be able to create this user variable. So let me show that to you. Let us compile this code, and here you can see that we have a compiler error telling us that it cannot find the symbol user in the else branch. So this user variable has only been created where it's relevant to use it, that is in the if branch and not in the else branch. If we had put a not in front of the InstanceOf, then it would have been the opposite. The user variable would have been valid in the else branch and not in the if branch. We can check that really quick. And now you can see that indeed the error comes from the if branch and not from the else branch. And now what we can try is create a Boolean value directly and try to make it with this AND operator. So let us make this Boolean equals to O instances of user and age equals user age. Now the scope is a little more subtle because we are in an expression, but indeed in this AND branch it makes sense to have a user variable. Why? Because if O is not an instance of user, we know that the other part of the AND operator will not be evaluated. And if it's the case, the nice thing is that we just have to return that and that's it. All the rest of the if can be removed, right? Let me fix the indentation real quick. Compile the code, which is still compiling, and run it, and the behavior is the same. So our code is working. We can do that. The compiler is smart enough to assume that this user variable exists in half of the expression, which is really great. Would have it been the same if we had put an OR operator instead of an AND operator? We expect not. Why? Because if O is not an instance of user, then we'll have to evaluate the second part of the operation, right? And in the second part of the operation, this user stuff doesn't make sense because O is not an instance of user. So expect this code not to compile properly. Let me compile that. And indeed, the compiler tells us that in the second part of the expression, this user variable does not exist, which is what we expected. So let us put this AND back and add the comparison of the names. Objects equal this.name, user.name, compile the code again and run it and see that everything is fine. So this is what this pattern matching for InstanceOf is about, changing the syntax of the InstanceOf, enabling the creation of a variable as part of the InstanceOf directly. Just a word of warning, remember that all I showed you is a preview feature, so it may change in the future versions of Java, and it may change before making it into general availability. At this point, you may think that pattern matching for InstanceOf is just some kind of small syntactic sugar that is nice to have, but that will not be a revolution in the language. In fact, it's not the case. Pattern matching for InstanceOf is part of a much bigger plan that includes deconstruction for records, sealed interfaces, and pattern matching in much more places than just the InstanceOf operator. So stay tuned for more information on all these points. And with this, I think we're done for today. Thanks for watching. Talk to you soon.